So in this case here, this is a geometric sort of problem, and what the problem says is that if you have 5 points you're going to select out of an equilateral triangle, and we'll just fix the side length at 1, which is real convenient, then at least 2 of these 5 points are within a half unit of each other. Very different sort of feel to it maybe from what we've been doing with the pigeonhole principle, but let me show you the pigeonholes. I'm going to draw the triangle and show you the pigeonholes. By the way, this can be done with various regular shapes like this equilateral triangle. So in this case here, the equilateral triangle would look like this, like so. And so you have to imagine it's drawn perfectly, right? It's not, but it's close enough. So these are all side lengths of 1. Now what I'm going to do with it is actually divide it into 4 pigeonholes, 4 boxes. And so for this, I'll take our green color and draw the midpoints there, and draw these 4 congruent subtriangles. And let's see, what is the length of the side here? Well, when you take midpoints of a triangle, of the sides of a triangle, and connect them, then that side length is exactly half the length of the longer side down here. So this side length here is a half, a half, a half, a half, a half. They're all a half. They're all congruent. So I'm probably overdoing it to put them all in there, but they're all a half. Now there's 5 points in there and 4 pigeonholes. These are the 4 pigeonholes. So at least 2 of the 5 points lie in one of the triangles. I don't know which one. Okay, it doesn't matter, but 2 of them are going to lie in one of the triangles like that. Now here's the deal. Because the corners here are going to give us the maximum distance between points in the triangle, and with the equilateral they're all half, so the maximum distance between points in the triangle is 1/2. So 2 points are within 1/2 of each other. Yeah, isn't that cool? And finally, we'll end up with this next one. It is even more interesting, I think, and there's just a lot of them like this. As I say, there's some sophisticated things that we can prove using the pigeonhole principle. So this one here says a list of 10 positive integers. I don't care what they are or how they are arranged. Doesn't really matter. A list of 10 positive integers has a sublist in the same order. So it could be the whole thing. It could be one of them. But whatever ones we choose out of here, say we chose 4 of them, they're in the same order as the original 10, whose sum is divisible by 10. In fact, the sublist can be chosen so that it's consecutive. In other words, what I'm trying to say is x2, x3, x4, x5, consecutive in the list, not just in the same order, but consecutive, as we'll see. So here's how we're going to go about it. So first of all, I'm going to take all the possible lists that just start at 1, x1, x1 plus x2, x1 plus x2 plus x3, through x1 plus x2 plus x3, etc., to x10. So there's 10 of these. There's one of them. There's one. There's one. I'm underlining them just to distinguish them, so you can see that there are truly these 10 sums here all starting from 1 and ending someplace along the line there from 1 up through 10. Now, it is possible one of these is divisible by 10, but I'm going to allow myself other kinds as well. So if 1 is divisible by 10, we're done. If not, then none of them's divisible by 10, and there's 10 of them. If not, each has a remainder among 1, 2 through 9 when divided by 10. So there are 10 sums. Yeah. And there are 9 remainders, which are the pigeonholes. So 2 of these have the same remainder. 2 have the same remainder, say x1 plus x2 plus through xj, and x1 plus x2, etc. through xk have the same remainder, so their difference is divisible by 10. Wow. Okay, if they have the same remainder, then when you subtract one from the other, the difference will be divisible by 10. And what will the difference be here? That would be, okay, assuming k is bigger, assuming k is the bigger one, then if I take the difference, it's going to go from xj plus 1 to xj plus 2 all the way up to xk. That's this thing minus that thing, right? So xj would be subtracted out there, so xj plus 1 is the first one. So there it is right there. Yeah? Okay. Very nice little application here.